All right, so this is the Krebs cycle. Can read that. All right, looks okay. Let's roll with it. So the Krebs cycle starts out with the two pyruvates that we got from glycolysis. Now I'm only going to write one Krebs cycle. I write everything in terms of the cycle happening one time, but in actuality it happens twice because we got two pyruvates from that glycolysis cycle. So I'll touch on that at the end, how, at the end we're essentially just going to double everything. Yeah, so here we go. So the two pyruvates, they will come over in, come down, and create acetyl-CoA, and it will also get rid of, let's use orange here, we'll get rid of NADH. Alright, so pyruvate will come down, get rid of an NADH, and become acetyl-CoA. It'll do that thanks to pyruvate dehydrogenase. This is an enzyme complex, meaning it's really a group of more than one enzymes combined. They all do a similar thing, so they all are put into the same category as a pyruvate dehydrogenase complex. So we have that. So now the pyruvate has turned into acetyl-CoA. Acetyl-CoA is a 2-carbon substrate here. I'll put 2 small little C's there just to document that. And the acetyl-CoA will enter into the Krebs cycle and join up with oxaloacetate right here, as you can see right there. Alright, good. It'll join up with oxaloacetate and create a citrate right there, and it'll do that using the enzyme citrate synthase. Citrate, let's add that in here. Alright, so now we're rolling here. So from citrate, let's touch on oxaloacetate is a 4-carbon substrate here. So we have acetyl-CoA and oxaloacetate. They're combining. They're making a citrate that becomes a 6 carbon. You can see 6 small C's there, just to document that as we progress here. So the citrate will come down and form, let's put it right about here. We'll try to make this circle as perfect as we can, but I guarantee it's not going to turn out that way. So citrate turns into cis-aconitate. There we go. Which remains a 6-carbon. 2, 3, 4, 5, 6 right there. And that happens thanks to, let's draw an arrow to get this circle rolling. That happens from the enzyme aconitase. Alright, so we have that. And from cis-aconitate to isocitrate, put that out here, isocitrate. This happens with the same enzyme, aconitase. Alright, make sure that's legible. Looks like it is in the video. Alright, and nothing really special has happened here. We've picked up an NADH, which is actually 2 NADHs, thanks to the 2 pyruvates. This whole cycle is happening twice. But other than that, not much has really happened. So we go from here with isocitrate. We move on. The isocitrate turns into, let's see here, an alpha ketoglutarate. Right there. It does that thanks to, let's put the enzyme in here. The enzyme is, this is a complex. This is the isocitrate dehydrogenase complex right there, as you can see there. Okay. So this is the first step. So the isocitrate was still a 6-carbon, but now's where it gets a little interesting. We lose a carbon to CO2, but we pick up another NADH. Okay, so we lose a carbon there, pick up another NADH, alpha ketoglutarate. This and turns into succinyl CoA, yeah, CoA. Little nice little arrow here. Succinyl CoA, and the same thing happens here. This is an enzyme complex. This is a alpha ketoglutarate dehydrogenase complex, and the same thing happens as far as losses and gains. So we lose a CO2 and we pick up another NADH. Alright, so there we go. And from succinyl, we're gonna extend this a little bit to try to make this circle an actual oval circle thing here. So from succinyl CoA, we go to just a normal succinate, and this is by a succinyl CoA synthetase. Let's see if we can't get this done. There you go. Focus a little bit. There we go. So now we have this. In this process, we gain something, but we don't gain another NADH. We actually gain an ATP through the form of a GTP. For this purpose, it's essentially the same thing. So we'll call it GTP, ATP. We're going to roll with that. And from then on, we have succinate turning to fumarate, and then turning to malate. So we'll draw some arrows here just to depict that. There we go, just to get that shape rolling, and then we'll talk about the enzyme. So the enzyme from succinate to fumarate is a succinate, another complex. It's a succinate dehydrogenase. And then here, unlike an NADH and a GTP, we pick up an FADH2. Another form of creating energy, and we will do that. That comes in the next cycle, next system here. So then from fumarate to malate, there we go. It's a little out of focus, but it's legible. Fumarate to malate, we are going fumarase is the enzyme here. Fumarase. There we go, and nothing changes there. Nothing gained, nothing really lost. Just a change from fumarate to malate, and from malate to oxaloate, a malate dehydrogenase dehydrogenase is used to facilitate that change, and then gained is another NADH. NADH. So here we go now. We have oh, there, come on, focus for me here. There we go. So right here we have with everything written out as far as how this cycle goes. So remember, everything's now times 2. So we get 2 pyruvates coming in, and then that creates 2 NADHs right from the get-go here, right up here. So we have immediately 2 NADHs created. And as we move down through this system here, we have another 2 here, 2 here, 2 made here, and we have 2 ATPs made down here, 2 FADH2s, and then another 2 NADH. So if we look at what we've got here, we are, I'm trying to get my pens in order here. We are picking up, where do I have space? Right around here. We're picking up, we're adding 2, 4, 6, 8 total from when the pyruvates begin to change to acetyl-CoA. 8 NADH. We're adding 2 ATPs, and we're also adding 2 FADH2s. So that's what we got here for the Krebs cycle. We're now to, this is our return. Obviously these will all yield ATP a little bit later down the line. NADHs, some of them add up, equal out to about 3 ATPs, as well as the FADHs. So there's the Krebs cycle. There it is. There's the enzymes and where all of the NADH molecules and other ATP, FADH molecules come into play.